This project is kind of a doozy. It's got a lot of subtleties to it. This has to do with passing by value, passing by reference, and passing by pointer. I'm going to try and cover some of what pointers are. They're a very important concept in C++. I'm going to talk about using primitive types. Later on I'll get to how pointers with structs and classes work. So to begin with, I've created a project which gives you some idea of what's going on. So what's going on here is I'm eventually, if I'm doing this correctly, going to create a power function which passes by value, a power function which passes by reference, and one which uses pointers, which is another way to do by reference. And it uses all sorts of funky symbols. So to begin with, passing by value. So when I use parameters that are just like the type and the name, so float a, int x, what happens is when I actually call this function down here, I get an answer. For example, let's say I say my answer is a. Obviously that's not power. I'm not showing you how power works, but this is an example of how by value works. If I return that answer as a float, I get that back up here because I'm assigning my result to that thing. But notice that if I take this float a and assign it a value in the middle of this, so 27, if I run this code, up here at the top is the by value section. Notice that even though I changed the value of a down here, it didn't change what this original number up here was. When I printed out number, it was still a 3. So by value, what that means is this parameter a actually gets a copy of what is in number. It doesn't get the actual original variable up here number. So it gets a new copy of a. So if I change a, it doesn't mess with the original number. So that's called by value. Now, just in case, let's reset number to 3 and call by reference, the power by reference. And that uses this little ampersand on the a up here and down here. So that is by reference right here. So when you use the ampersand on a primitive type, just the floats or ints or whatever they are, what you're getting is the address of that thing. So notice down here, if I take a and make it a 27, when I print out my original number, number has changed as well. So this is by reference. I am actually passing the original variable in here. And if I change this parameter a, I'm changing the original number that it came from up here. So this is passing by value, passing by reference. So now, pointers. So the ampersand symbol basically means the address of that thing. The star means a pointer. So if I say float star a, I am creating a pointer to an address. So right here, if I create a floating pointer and it is set equal to the address of number, what this means is this is a special kind of variable that only holds addresses. It only holds memory locations. And the type of address it's going to hold is to a floating point number. That's what this means. So float pointer. And what I'm doing is I'm putting the address of number in there. And so I'm going to pass that in, the pointer in here. So notice up here in the function prototype, this is a float pointer a. And down here, I'm also matching that. So if I actually print out what I get inside of the method, that's this section here, and here actually. So if I print out what is actually in a pointer, right there, if I just print out what a is, notice it gives me this hexadecimal thing. So if you've never learned hexadecimal, it's basically a way of representing lots and lots of binary numbers more efficiently, and it uses 0 through 9 and a through f, which are basically the numbers up through 15. So this is referring to a particular binary location in memory that's been given to me as a floating point address. So that's what a floating point pointer has in it, or any pointer has in it. It's going to have some sort of memory address. If I use the star in front of it, that is the thing located in that memory address. So it gives me what's inside of a. So a is actually pointing to this number. And if you look right here, when I print it out, So I print out star A. That is a 3. So the thing located in this memory address is a 3. That's what I assigned right there. Number is a 3. The pointer's pointing to the address of number. And if I try and get whatever's out of pointer, it gives me back my original value. So it's kind of a layer of abstraction here, where you're one level removed from the actual data you want to get out. So why is this useful? Well, this is another way of passing by reference. So if I do star A equals a different value, notice down here when I print these out, the memory location is the same, but I've changed the actual value inside of it. And if I actually go back out again, the number here is actually changed. So when I changed the value of the pointer to 27, I was actually changing my original value up here. And by the way, if I print it out again, so if I print out what the address of number is, notice that this location of where number is the same place the pointer had in it. So the memory location was the same, which is why I can actually change the original value of number. So that's the idea behind by value, where you actually just pass in regular primitive parameters. If you pass in regular parameters, then it makes a copy of it here, and if I mess with the original value, it has no effect on the original number. So the number stays the same. If I pass it in by reference, using this address of sign, that actually gives me the original value, and I can actually change it. So when I change to 27 here, it changes there. And finally, pointers, you can actually, you take a particular memory location and you can change what's in that memory location, which is what I've done here. So I have this pointer, starts with this value, and then I give it this value. And this memory location is the same as the original variable. All right, I think that will get you through reference, values, and pointers.